Okay, so welcome everyone to today's lesson. We are looking at the relative atomic masses. Okay, so we have to know the definition of the relative atomic masses, and then we'll talk about a bit about what isotopes are. Okay, and how we can use the different isotopes of a certain atom or a certain element to actually calculate the relative atomic mass. Okay, so those two are the main objectives for this lesson that we are having today. Okay, so the first thing there, we have to define this guy here, the relative atomic mass. Okay, so I'm sure you've seen somewhere where you have this word as RAM. Okay, so this RAM here simply means relative atomic mass. Okay, so is there anyone who knows how to define this relative atomic mass? Anyone who can define, who can help us define what relative atomic mass is? Anyone? Okay, so relative atomic mass is just the relative atomic mass of an element is the mass of one of its atoms, okay, relative to 1/12 the mass of one atom of carbon-12. So it's like we're getting the mass of a certain element, and then we are combining it to the mass of carbon-12, okay? So what is carbon-12? Carbon-12 is the standard element in which we compare all the relative masses to, okay? Of course, some books can have different definitions of what the relative atomic mass is, okay? So it's just the mass of one of its atoms relative to 1/12 the mass of one atom of carbon-12. Okay, so that's the best definition for the relative atomic mass. So the word relative, meaning you are comparing it to something, okay? So you are comparing this atomic mass of a certain element, okay, to 1/12 the mass of carbon-12. Okay, so that's the standard definition for relative atomic mass. Okay, so this relative atomic mass now comes about due to what we call as isotopes. Okay, I'm sure most of you know what isotopes are. So what are isotopes? Anyone? What are isotopes?
Okay.
Mm-hmm.
Isotopes are atoms having the same number of protons but different neutron numbers.
Exactly. Okay, so these isotopes are atoms, okay, of the same element. So meaning if I have this atom here, chlorine, okay, so atoms, I can have two different atoms of this chlorine here, and then those atoms, I'll be calling them as what? Isotopes. So isotopes are just atoms of the same element, okay, but they have different number of what? Neutrons, okay. So remember, when you go on the periodic table, okay, when you go on the periodic table, any element is represented in this form, okay? Any element is represented in this form. We have this X that will represent the symbol of the element, okay? And then on top here, or just at the corner here, top right, top left corner here, you'll find A, okay? And the bottom left corner, you find Z. So this A here, okay, means the mass number. Okay, this here means the mass number. And then this Z here means the atomic number. Okay, atomic number. So now, this mass number here is a combination of two things. Okay, it's a combination of the proton number plus the neutrons. So if we go back to grade 12 and you draw those circles for electronic configuration. We said in the nucleus here, we have protons, okay, and neutrons. And then surrounding this nucleus, we used to say we have what? Those electrons like that, okay? Those electrons like that. So these particles that are in the nucleus, okay, when you count them and then you add them, they are what forms the what? The mass number. So you get the protons, you add them to the neutrons, you are going to get the mass number. And it is this number that is on top left corner of the element. Sometimes can even be here, okay? And then on the bottom left here, you have the atomic number, okay? So this atomic number is what? Is the number of protons, okay? It's the number of protons. Now, a funny thing is that when you go on the periodic table here, where is the periodic table, okay? When you go on the periodic table here, so this is the periodic table, okay? So for this one, they have like swapped, okay? On top, they're having the atomic number, and then down there, you're having what? The mass number. So the mass numbers are these two. Let me zoom in on some of these elements just to show you. So you've seen this element here. For example, if I get the lithium, okay? So the number that is on top there, okay, is the atomic number. And then the number that is down here, you've seen it, the one with a lot of decimal places here, is what we are calling as the mass number, okay? So this mass number that is shown on the periodic table, okay, it is the average of all the isotopes. It is the average of all the isotopes for this element here, okay? So this element, beryllium, will have isotopes, okay? It can have 2, it can have 3, it can have 4, whatever the number of isotopes that it has. And then when you get the masses of those isotopes, okay, and then you find the average, that average that you find is the one that they put on the periodic table. So all these decimal numbers, these ones here, okay, the ones that you can see here, are what? Are just average of the isotopes for this specific what? Element, okay? So today now we want to focus on how to find this same mass here given isotopes of that element. That's what we want to do, okay? So we are finding this mass number here using the isotopes that we've been given for it, okay? So that's what we are going to focus on. So these are the questions here. They are on finding the relative what? Atomic mass, okay? So any questions there before we solve any question? All right, okay, so under this concept of finding the relative atomic masses using isotopes, we have mainly 2 types of questions that come, okay? So the first one is there where they're asking you to find the relative atomic mass. Sometimes they just say average atomic mass, okay? So average atomic mass, relative atomic mass, it will mean the same thing, okay? So they will give you the isotopes for that element. Then they'll give you the atomic mass of each of those isotopes. And then they'll also give you the abundance, okay, or what we call as the percentage of that isotope in that element, okay? And then you'll be asked to calculate the average atomic mass or the relative atomic mass, okay? And then in another case, so these are the 2 cases. In another case, you won't be given the isotopic abundances or the percentages, and that will be your job to find. So you can see on this question 2 here, we do not have the percentages here, okay? They have not given us the percentages here. So they want us to find what percent is this isotope and what percent is that isotope, okay? So those are the 2 main questions when it comes to questions that involve relative atomic masses using these isotopes, okay? So we use this formula to find the relative atomic mass. So it's a very simple formula. You have to memorize it, okay? So relative atomic mass is just equals to, okay, the mass of isotope A, okay, multiplied by the percentage of isotope A, okay, and then you put them in brackets like this, and then you say plus the mass of isotope B multiplied by the percentage of isotope B. Okay, so if you have 3 isotopes, you continue, say plus the mass of isotope B, and then multiplied by its percentage, right? Okay, so in this case, this formula will be for isotopes A and B. Okay, so if you have a third, you add another bracket there. Okay, if you have 4 of them, just add like that. Okay, so this will be the formula that we'll be using. Okay, so you just get the mass of this isotope multiplied by the percentage, and then plus the mass of this isotope, you also multiply it by the percentage. Then whatever you get will be our what? Relative atomic mass. Okay, so now let's solve question 1 here. So question 1, they are saying a sample of natural copper is vaporized and analyzed in a mass spectrometer. Okay, so this mass spectrometer here is just an instrument that detects the isotope of a certain element. Okay, and then they're saying the spectrometer detects 2 isotopes. Okay, we have copper 63 and copper 65. Okay, and then they're saying the following data is recorded. So here you have the isotope, its mass, and its isotopic what? Abundance. Okay, so for copper 63 here, we have the atomic mass as given as 62.93. And then for copper 65, we have 49 and then 0.93. Okay, and then we are told this one has a percentage of 69.01. This one has a percentage of 30.91. Okay, and then the question is calculate the average atomic mass. So this average atomic mass is the same as the relative atomic mass. Okay, so let's calculate. Okay, so we're going to say the relative atomic mass. Okay, so notice that there we only have 2 isotopes. So the mass of chlorine 33. Okay, the mass of chlorine 33 is what? This guy. And then we multiply it by this percentage, and then plus this guy multiplied by this percentage. Okay, so we are going to say 62.93 multiplied by the percentage for this guy was 69.09. So make sure that you divide your percentage by what? 100. Then you say close bracket, and then you say plus. Okay, so the other one we had 64.93 multiplied by 30.91. So this 30.91 was the percentage, so we divide it by what? 100. Okay, so you just get your calculator and we try to punch these values to see what we're going to get. Okay, so what are we going to get? So you'll be counter-checking with me. My calculator may be wrong. Okay, so I have 62.93 multiplied by 69.09, and then I'm dividing it by 100. Okay, so what am I going to find there? Okay, so I'm finding 43.4783, and then plus, let's multiply this side here. I have 64.93, and then multiplied by 30.91 divided by 100. Okay, so here on the other side, I'm getting 20.0698 and then 7. Okay, so to find the final relative atomic mass, okay, so relative atomic mass, I'll add these guys here. Okay, so when I add these guys, what do I get? Okay, so plus, let me say 43.0783. So I'm getting this 63.548163. So I can round off these to 4 significant figures. Okay, so I can say this is 63.55. atomic mass units. Okay, so this here is the relative atomic mass for copper. Okay, this is the relative atomic mass for copper. So any questions there? I'm sure it's very clear, right?
Hello, sir. I would like to know the SI unit.
SI unit for relative atomic mass.
Yes.
It's atomic mass unit. So this what I've written here. This AMU, atomic mass unit.
Okay, thank you.
I also have a question.
Yes.
Is it that you're always supposed to round off to 4 significant figures, or you're always given the question?
No, but you don't always round off to 4. In fact, if anything, you are supposed to round off to 3 significant figures. Okay, but just keep it 4 to be safe. Unless the question states that you round it off to this number of significant figures, but you can leave it to 3 significant figures to 4 significant figures. There won't be a problem.
Okay.
Okay, so this mass here, if you go on the periodic table, what does copper have? Let's go on the periodic table. Okay, so when you go on the periodic table and you look at this copper here, let me zoom in copper. Okay, when you look at this copper here, you've seen this relative, this atomic mass. Okay, so this atomic mass here was obtained by adding the average of what? The atomic masses for the isotope of this copper. So you can see 0.546. If we put it to 4 significant figures, it will be exactly what we found, right? Okay, so always round it off to 4 significant figures or 3 significant figures. There won't be a problem. Okay, all right, and then let's look at the other question now. So in the other question, we are not finding the relative atomic mass, okay? Instead, we are finding the percentage abundances, okay? So there are 2 things that we have to take note, and I'll show you. Okay, so let's look at this question 2. Okay, so question 2, they're saying europium naturally occurs, okay, as 2 isotopes. There's europium 151, and then there's europium 153, okay? And then they are telling us the average atomic mass of europium is what? 151.96 atomic mass units. Okay, so meaning they've already calculated using these 2 isotopes. Okay, and then they're saying the following data is provided. Okay, so for europium 151, we have this atomic mass. Europium 153, we have this atomic mass. Okay, and then the question now is determine the relative abundances of what? Of the 2 isotopes. So meaning we have to find the percentage of this guy here, and we also have to find the percentage of this guy. Okay, so some students struggle on where you can get the second equation. Okay, so because here we have to come up with 2 equations, and then those 2 equations we are going to solve them simultaneously to find the answer. Okay, so we are going to say let the percentage for this, I think let me be writing here. Okay, so let the percentage, okay, let y% be for 151, okay, europium, and then let x% be for the 153 europium, like that. Okay, so the first equation, we get it right here. Okay, so we know that when we add the percentage of this guy here and the percentage of this guy, we should get what? 100%. Okay, so we are saying x% plus y% should give us what? 100%. So this here will be our equation what? 1. And then where do we get our equation 2? We get it from the formula for what? For the relative atomic mass. So remember, relative atomic mass, we said that this is just mass of the first isotope. Okay, for example, isotope A multiplied by the percentage of isotope A and then we say plus the mass of isotope B, then multiplied by the percent of what? This isotope B, like that. Okay, so here we have two isotopes, these ones and this one. Okay, and then in the question, we have been given this relative atomic mass. Okay, so we have been told that the relative atomic mass is what? Okay, we are told that the relative atomic mass is 151.96. So you put the relative atomic mass there, then we are going to say this is equals to, what was the mass of europium 51? This guy here. Okay, so you check here. So you get this mass here. You go and put it into the formula. Right, so we have 150.9196. Okay, so we are going to say 150.91.96. This should be 96. Let me write it properly. Oh, what's happening to my pens? Okay, so we have 150.9196 as the mass of the first isotope multiplied by X divided by 100. Oh, we said this was Y, right? We said this was Y for the 51. So we're going to use Y there. So we're going to say Y over 100. And then plus, for the other one, what is the mass? The mass is 152.9209. So we're going to say 152.9209. Okay, and we are multiplying this by the abundance of what? X divided by 100. Okay, so this is what we have here. Okay, this is what we have. So what are we going to do? We are going to divide this number divided by 100, this number divided by 100. So we have 151.96 is equals to, what is this number divided by 100? Okay, so you get your calculator, your punch. So 150.9196 divided by 100. I'm going to get 1.5. Okay, so 1.5 and then 0.916. It should be a 9 there. So we have 96. Then we are multiplying by Y, and then plus. We divide this by 100. This decimal place just moves to the left by 2. Okay, 2 times. So it will be 1.529.209. And then this is what? X. Okay, so this is what we have. Okay, so this, what we've written here is our what? Our equation 2. Okay, so now remember that our equation 1 was just X plus Y is equals to what? 100. So from this equation 1, we can make one of them to be the subject of the formula, and then we substitute on the other one. Okay, so we can make one of them to be. Okay, so which one can we make? Okay, let's say X is equals to be 100 minus what? Y. So that will be our value of what? X. So wherever there's X here, we are going to put 100 minus Y. So this is going to be 151.96 is equals to 1.5 0.9196Y, and then plus, okay? So here, where there's X here, I've put 100 minus what? I'll put 100 minus 1. Okay. So it means I'm multiplying this number here by 100 minus 1. Okay, I'm multiplying this number here by 100 minus 1. Minus Y, I mean. Okay, so this number multiplied by 100, what am I going to get? I'm going to get 152.9209 back. Okay, and then this number multiplied by Y, I'm going to get minus 1.529209Y. Okay, so this is what I'm going to get there. Okay, so from here we put the like terms together. So all those with Y, okay, we can leave them on the right side, and then those without Y, we can take them on the other side. So on the other side, we have 151.96 0.96. And then this guy here comes to the other side, so it becomes minus 152.9209 is equals to, and then here we are having this guy and that guy. Okay, so let's get our calculator and punch in. So do 1.509196 and then minus 1.5292. Okay, 1.529209. So if I subtract that, I'm getting, according to my calculator, I'm getting minus 0.020013y. Okay, and then we also have to subtract this side here. So there, on the other side, I have 151.96 minus 152.9209. Okay, so what do I find there? Okay, let me redo this. So 151.96 and then minus 152.9209. Okay, so I'm finding this. Okay, I'm finding minus of 0.9609 is equals to what we have here. Y. Okay, and then from here, we just have to divide. Okay, we divide both sides by this number here. So let's try to divide and see what we're going to get as our value of y. So we divide this side by this same negative 0.0200113. Even on the other side here, we divide by the same minus 0.0200113. Okay, so means our y is going to be equals to this, and this will cancel, and then we are dividing this one out. Okay? So we have 0.9609 divided by 0.020013. Okay, so when I divide that, I get 48.01379. Okay, so this is the answer that I get. So it means y is this percent. Okay, so let's round it off to 4 decimal places. So y will be equals to 48.01%. Okay, so we found the percentage of the first isotope, okay, which was 151 europium, like that. Okay, so now to find the percent of the other one, what do we do? Okay, we just use this formula here. We know that x is just 100 minus y. So we are going to say x is equals to 100, and then we subtract with the y. So it will be 48.01. So this is going to be equals to what? Okay, so 100 minus 48.01. Okay, so what am I getting now? 100 minus 48.01. Okay, so I'm getting a 51.99. Getting a 51.99%. Okay, so we found the answers there. Okay, so for the first one, which was this isotope here, okay, we're going to say its percent is just 48.01%. If you want, you can round them up to 3 significant figures. And then for the 153 europium, we are saying it's 51.99%. Okay, so that's how we go about that question. Any questions there, guys? Okay, no question. All right, so that was the class for today. Okay, hope you've learned something. Okay, and then I'm going to give you a task as usual. So you guys, you didn't submit the task I gave you yesterday in math. I gave you a task and I didn't see people sending me answers. I don't know what you're doing with the task, but you should send me answers. Okay, you have to practice what we learn. Okay, so for today you can try to solve this question here, the question 3. Okay, so it's on the chlorine atom, and then you've been given anything, and then they are asking you to find the average atomic mass. Okay, so you can find it, and then you can send the answers. Okay, so any other questions before I end the class? Okay, no question. All right, guys, have a blessed night, and thank you for attending the class. So tomorrow we have physics. Okay, so don't miss the class for physics.
All right, thank you.
You're welcome.